You're live. Hello. Hello, everybody. Hello, everybody. Hello, Franklin. Thank you for helping, Franklin. So, we're now on another session of anti-relativity. But first,
Okay, ready to go?
yeah, first we want to play you a little video clip saying we need some money, please.
Hello, my name is David D. Hilster, and I'm president of the John Chappell Natural Philosophy Society. Our organization is unique in the world in that we allow for serious criticisms of mainstream science from physics to cosmology and from math to philosophy. And today, this organization resides 100% online. If you enjoy our Saturday morning talks, our websites, and the community of amazing critical thinkers you can interact with on the internet, then please consider contributing to our annual fund drive. It costs almost $3,000 per year to keep our internet presence and our Saturday morning talks alive and well. I want to thank all of our members who pay monthly and annual memberships, which is vital to our day-to-day operations. But unfortunately, this is not enough, and that's why we're looking to raise $2,000 in our 2024 drive. So if you don't want this organization to disappear, and you think that its mission is important, then please consider donating to the CNPS. It's vital to keeping science moving forward. Please go to fund.naturalphilosophy.org and donate today. Thanks once again from all of us at the CNPS. Your donation is vital.
So, I'm back again, hopefully. So, that's the important message. We need some money, please, to help us carry on. So, on now to Anti-Relativity Session 9. And Franklin, let me know if you can see this. Right. Yeah. Can you see that? Hopefully you can see that. That's the first slide. Anti-Relativity 9, Math Mistakes in Special Relativity. So, as pointed out in the previous talk, the mainstream, when they deal with relativity, when they talk about things, they start contradicting themselves. And example from previously was some of them say there's a preferred frame and some say there isn't. So mainstream does not agree on many issues in relativity. There is a difference of opinion. And Einstein's relativity is built on numerous differences of opinion. It's a collection of different opinions, hence it's not a precisely defined theory. So what they talk about is a mess. An example will now soon be given that what they deal with in the maths is also a mess. So I'd like to point out this person. He's Professor Ohanian. He's written a book called Einstein's Mistakes, and his research is relativity in quantum physics, and he's a PhD from Princeton University. And so he points out that there are many math mistakes in what Einstein's talking about. An example I'm going to deal with is Einstein's derivation of the Lorentz transformations. So, side note is some defenders of relativity will say their maths agrees with experiments, but what they talk about is a mess, and the mathematics they use is a mess, so all they're doing is applying a mess to experiments. So what I'm doing is going for a few things mentioned in this paper by Alexandra. It's called The Mathematical Invalidity of the Lorentz Transformation in Relativity Theory. And the paper he's referring to by Einstein is in this book, Relativity, the Special and General Theory. In this book, he has Appendix 1, and it's a simple derivation of the Lorentz transformation. And this is the diagram he's going by, where you've got two coordinate systems, x, y, and z, and you've got speeds v. Einstein says a light signal which is proceeding along the positive axis of x is transmitted according to the equation x equals ct. Then he gives equation 1, where x minus ct equals 0. Since the same light signal has to be transmitted relative to k prime with the velocity c, the propagation relative to the system k prime will be represented by the formula x prime minus ct prime equals 0. So what Einstein has is two systems, the k system and the k prime system, and he set up those two equations. So he then goes on to form equation 3, where he says x prime minus ct prime equals lambda, and that's all times x minus ct. But x prime minus ct prime is 0, and x minus ct is 0 as well. So really, equation 3 is saying 0 equals 0. So it doesn't really make sense. What's he dealing with an equation like that? And this is what Alexandra says for those equations 1, 2, and 3. Because of equation 1, 2, and 3, we can write equation 3 as 0 equals lambda times 0. One can postulate that meaningful values, which are at least something both different from 0, are somehow related. Introducing proportionality quotient between nothing and nothing has no meaning. Einstein then goes on to form this equation 4, which is x prime plus ct prime equals that, I think it's a mu symbol, all times x plus ct. And he seems to be using in this equation x prime as equal to minus ct prime, and x is equal to minus ct. Alexandra says explanation is inapplicable. If rays of light are traveling in both positive and negative directions of the x-axis, then one cannot combine their positive and negative x coordinates, as they represent different events. And it's like adding apples and oranges. So we have this equation from Einstein, and that's where I'm noting he seems to be wanting x prime is equal to c, as x prime is equal to minus ct prime, and x is equal to minus ct, when earlier he had them as the positive values. So he's now saying that x equals ct equal to minus ct, etc. Einstein's maths is beginning to not make any sense. So he's got these equations which are basically saying 0 equals 0, that's in equation 3, and 0 equals 0 in equation 4. And then things are going to start to get worse because he's going to combine those equations. So this is what Einstein has. He combines those equations and he ends up with two equations, which he's going to call equation 5. So he's using 0 is equal to 0 and getting these parameters a and b, but they're sort of meaningless because they're formed from using 0. Alexander comments, expression 6 is a cardinal error. Derivation begins with that's equation 1 with x equals ct for the front of the beam of light. Few lines below in equation 6, Einstein now presents relative speed of two coordinate systems as v equals x divided by t, and that is meaning x equals vt in the same context. So Einstein is now using vt is equal to ct. And we also noted earlier that ct also equals minus ct. So Einstein's ending up with nonsense. As Alexander is noting, what follows is meaningless. Einstein, from his meaningless equations of 0 equals 0, ends up with the Lorentz transformations. And this is what the Lorentz transformations look like. And so basically, for meaningless mathematics, Einstein has derived the mathematics of special relativity. Alexandra summarizes it as, by making such errors, one can derive nearly anything, Lorentz transformation included. Unfortunately for science, this is one thing that his many followers learned very well from him and happily applied. So people who believe in Einstein's relativity can follow Einstein's example and from meaningless mathematics get whatever they like. So the issue becomes for those defending Einstein and Einstein's relativity, saying that what a genius he was and is brilliant in math, he's a brilliant mathematician. Are they really defending the mathematics that was just shown? Because it looks like nonsense. Are they defending nonsense? It is possible that they recognize it's nonsense, but just don't want to address the issue of the mathematics like this being nonsense and just ignore it. And then they are just leaving it out there in the public domain uncorrected. There are more mathematical mistakes by Einstein than just pointed out in this talk, such as by this person here. Mathematical flaws in Einstein's on the electrodynamics of moving bodies. So if they're just ignoring the mathematical mistakes by Einstein, there is a vast amount of what they're ignoring. But it becomes worrying that maybe they don't think there are any mathematical mistakes by Einstein, such as just highlighted, and they just accept it as valid mathematics. And so they're totally messed up in their comprehension of mathematics. So the issue is vital in the sense of, are physicists genuinely believing the mathematical nonsense by Einstein? That was pointed out by Alexandra. If they think it is nonsense, well, they've not made it clear, and they left the mathematical nonsense out there in the public domain uncorrected. Given that it is nonsense, then they are just applying nonsense to experiments, and the whole scientific enterprise has become a waste of time as merely about them talking nonsense. Saying that they have confirmed the theory by experiment is meaningless when the theory is nonsense. However, consider the following. Right, this one. So this is a website dealing with the teaching of relativity, and it's from New South Wales, Australia. So after teaching the students about relativity, the students rebel because it does not make sense to them. The lecturer then responds, and I have to look closer in. So what this lecturer says, At this stage, many of my students say things like, the invariance of the speed of light among observers is impossible, or I can't understand it. Well, it's not impossible, it's even more than possible. It is true. This is something that has been extensively measured, and many refinements to the Michelson-Morley experiment and contemporary complementary experiments have confirmed the invariance to a very great precision. As to understanding it, there isn't really much to understand. However surprising and weird it may be, it is the case. It's true in our universe. The fact of the invariance of C may require some accepting, but it doesn't take much understanding. What requires understanding are its consequences and how it can be integrated into what we already know. So basically, what he's doing is he's asking his students to believe in nonsense because it's supported by experiment. However, as per this person, he's John Norton. He's an Australian philosophy of physics and distinguished professor of the history and philosophy of science, and he's expert in relativity. This is what Norton says. Uh, in addition to his work as editor of the Einstein papers and finding source material, Satchel assembled the many small clues that reveal Einstein's serious consideration of an emission theory of light, and he gave us the crucial insight that Einstein regarded the Michelson-Morley experiment as evidence for the principle of relativity, whereas later writers almost universally use it as support for the light postulate of special relativity. Even today, this point needs emphasis. The Michelson-Morley experiment is fully compatible with an emission theory of light that contradicts the light postulate. So basically, the light postulate of special relativity is not really needed for the Michelson-Morley experiment. And the reason why Norton has to emphasize this is there are people who are saying that the Michelson-Morley experiment supports the light postulate when it doesn't. So not only does the New South Wales lecturer ask his students to believe nonsense, he also lies to them about experiments. The experiments don't support the nonsense that he's teaching. So what we have, thus, the maths is messed up, the experiments are messed up, teaching of the subject is messed up, etc. So, thank you. That's the end of the talk, and I'm now going to show a video clip if I manage to find out how to get to it. Hopefully you saw that. Right then. Let's present. I've got to go present. Share screen. I'll go to academia. Share. So I'm playing this video clip where a person who looks similar to me is pointing out that academia uses logical fallacies to brainwash us. And that's basically what's going on with relativity. Not only they're messing up the maths, they're messing up experiments, they're messing up how they're talking about things, but they're messing up logic. And so I have this person explain it.
Fallacies that wouldn't have any logic at all. And I thought I should do a video following up on what I meant by that. And academia relies on using logical fallacies to brainwash you and me and everybody else. And if you look at logical fallacies, there are some that are pretty obvious that are used by academia. A being the appeal to authority fallacy. They want to be the authority and you have to believe them, even though they're
The reason they're in authority may have nothing to do with the actual argument they're trying to present. B, the genetic fallacies in play a lot. They make their decisions based on where they go to school, what country they're from, even the color of their skin. And yes, I don't like thinking of academia being openly racist, but over the last few years, you see people saying, well, if the study wasn't done in the US or Europe, we can't trust it. And that's racist. There's no two ways about it. And it's a problem. And certainly people from countries that are outside of Europe or the US, North America, they see it, they feel it, they face it. It's a reality in science and has been for a long time. And this can get even worse into ad hominem fallacies. I won't go into details. And then the bandwagon fallacy. This is one of the biggest ones of all. Scientific consensus is the bandwagon fallacy. Yes, we would like to believe that scientific consensus means that each scientist sits down, looks at all the facts, all the evidence, all the theories, all the competing theories, talks with all their colleagues, and they sit together and go, yeah, this really is right. But no, it doesn't work like that. You get a couple guys do that, and then they convince their colleagues, and then you end up with a consensus. They put it out in the media, and everyone else is just taught, well, these are the facts. Because that's the way schools work. They teach you facts. They don't teach you how to critically think through the scientific method and the scientific problem. So everything's the bandwagon fallacy, which is all these people can't be wrong because they all believe the same thing. Well, they all believe the same thing because they've been brainwashed. They've been told the same facts, and they haven't been told why those so-called facts could be, or maybe certainly are, wrong. As my videos show, it's pretty easy to poke holes in the facts if you do a little bit of investigation. You can find serious flaws in almost every major theory in physics, which is why we need to keep working on it. And then another fun one is the Texas sharpshooter fallacy. And if you haven't heard of it, this is a sharpshooter who shoots against the broadside of a barn and then goes over and paints the bullseye where his best grouping is. And that's what scientists do all the time, especially in physics. They talk about how their theory is the best at making predictions and is right about everything. And it's the Texas sharpshooter fallacy. Look at the cosmic microwave background predictions of the Big Bang. Most of them were off by a factor of 10 or 20. But now they say, oh, the Big Bang was perfect prediction of the cosmic microwave background. No, it wasn't. The best predictions actually were based on light energy, not the Big Bang energy. But they go back and they say, oh, we made all these best predictions after they fudged their theory to match the observations. Physics relies on the Texas sharpshooter fallacy to make their claims about how great their theories are. And then we can look at just how the academic system is built. So they set up a set of degrees where the higher the degree, the better authority you are, which is an obvious appeal to the authority fallacy. The degree you have has no bearing on whether the argument you're making is correct. And then they talk about what university you attended or where you taught at, and how most of the professors come from the top dozen universities in the US. So you're basically looking at, are you part of the bandwagon? Are you part of the echo chamber? And people from universities that aren't among the top tier are looked down on, and their arguments and papers aren't weighted as highly. The genetic fallacy. And then you look at the number of papers, as if producing papers in numbers had anything to do with a logical argument, or the number or value of grants that you've earned. Yes, academia needs money, they need grants. But that doesn't mean that the arguments you're making are right. In fact, people who are trying to get funding and make grants are known to stretch the truth a little bit from time to time. So, no, you can't trust that, and you can't trust the arguments. And then after you do publish papers, you have numbers of views and numbers of downloads, and they're nice. I love that I have subscribers and viewers and get downloads on my papers because I know my work is getting out there. But that doesn't say that my argument's right. That doesn't say it at all. In order to determine arguments right, people have to step through the logic and the evidence. And by the way, I should have put logic as a total different category. People often talk about what they think the scientific method is, and they never do a logic check on their hypothesis to see if it's even possible. They go straight to the observations and evidence. And so that's a step where academia avoids logic at all, at least in the scientific fields. And then passing peer review. And once again, we're in the bandwagon fallacy. Are you part of the echo chamber so that your idea passes peer review? Or maybe the current theories haven't worked for 50 or 100 years and there needs to be a new paradigm, but the peer reviewer won't pass it because if you come up with an idea that might be a successful new paradigm, it's going to make them look like a fool for their entire career. So no, the peer review system doesn't work. And what's worse nowadays is some of the papers that do get through that aren't standard physics are clickbait. Let's face it, a lot of what gets out into the public media gets there because it's clickbait. Editors are choosing papers to publish based on them being good clickbait. That's not good science at all. And it's certainly not logical. It's not an argument for something being true because it's good clickbait. And another one I love is number of citations. Once again, we're in the bandwagon fallacy and we're in the echo chamber. People using the same argument over and over again, usually that's been failing for 50 or 100 years.
The British Red Cross was made for moments like this.
So citations doesn't really tell you whether or not the paper was correct. Sometimes I cite something because it's incorrect and it's an example of something being incorrect. So in that case, it's not even useful at all in terms of something being a valid argument. And then we have, what level of professor are you? Are you an assistant or a full professor, tenure track? Do you have tenure? Are you a retired professor who's gone a little kooky, as they love to say? That doesn't have anything to do with whether or not an argument's actually correct. Some people do their best work when they're young, and yes, some people are braver when they're older. I certainly am. I don't have anything to worry about. I'm retired. So I can say what I really think of people's scientific ideas, and not have to worry about it because I'm not looking for a job. And then you have things like award and invited lectures. And I've gone through the list of Nobel Prizes, and half of them are wrong. 100 years from now, we'll know that they weren't right, at least half of them. The ones that are based on experiments, of course, they're right. If you have actual experiments that you run, for the most part, they're going to be right. They meant not going to be overturned. But a lot of the theoretical work, it needs improvement. And some of those we already know, but we're going to know a lot more. And these are just a few of the things, but if you think about all the standards academia puts on, like an H index or other indices for how good of a professor you are, that has nothing to do with whether your argument on a certain topic is right. It has nothing to do with whether the theories are right. And so, as I said, academia, if it wasn't for logical fallacies, it wouldn't have logic at all. And which is a good reason not to trust academia. And I didn't even mention, I follow physicists on Twitter, and there's a meme of not trusting engineers that are doing physics or science work. There's a joke about how many engineers are crackpots. Well, engineers aren't inherently crackpots, and most engineers could be scientists, and some scientists end up doing engineering. There's not that big of a difference between being a scientist and an engineer in capabilities, certainly in training on certain topics. And that's where academia really does help. It does give you training, and it does help you solve certain problems. And there are certain fields where without that training, you couldn't do the job, you couldn't do the experiments. But getting the training alone doesn't mean that you're the authority and that your argument's right and everyone else is wrong. You have to dig into the details of the argument. And I'll say, anyone who watches any of my videos, listen to what I say, listen to my arguments, think about the arguments. Don't just believe me because I say it. I try to be logically rigorous. And if I make a mistake, point it out in the comments. I'd love to go back and fix my mistakes. So anyway, I hope you enjoyed this video. And if you
So, hello, back again. And Ray Fleming there pointed out the logical fallacies that the science community makes, especially with respect to things like relativity. Now, apparently, the slides didn't show, so I'll try to show them again. They worked at the beginning when I tested it with Franklin, and unfortunately, Franklin has had to go. So I'll try see if I can try to get the slides up again. Share screen. Entire screen. Yeah, share. So it's that. And that's supposed to show the slides. So if I just check now myself, let's see if that's come out. No, what there? Oh. So. Yeah. Right, so it looked like it worked that time, so I'll quickly go through the slides. Unfortunately, I can't see the comments when I'm showing the slides, so just going to hope that the slides are going to be shown this time, and I'll just go quickly through them. So this is the title of the talk, Anti-Relativity, Math Mistakes in Special Relativity. And I pointed out what I was talking about last time, and I pointed out this book by a physicist, sort of scientist who specializes in relativity and quantum physics. He's written a book called Einstein's Mistakes, and he's pointed out that Einstein made a lot of maths mistakes. So the relevant paper that I wanted to go through was the mathematical invalidity of the Lorentz transformations in relativity by Alexandra. And what he was criticizing was Relativity, the Special and General Theory, a book by Einstein. And in that book, Einstein has Appendix 1, where he's stating the simple derivation of the Lorentz transformations. So Einstein is writing this equation x equals ct, and he has x minus ct equals 0 as his equation 1. And that's in the k system. And then he's going to write something for the k prime system. And he's writing for the k prime system as x prime minus ct prime equals 0. That's equation 2. And then he's going to form equation 3, which is essentially saying 0 equals 0. And so Alexandra says about this being meaningless, that equation 3 is meaningless. And then Einstein forms equation 4, where he seems to want x prime is now equal to minus ct prime. So that ct, so that x prime plus ct prime is equal to 0. And so he's got equation 4 where he's got 0 equals 0. So Alexandra complains about that. So Einstein has this equation where he now seems to be saying that x prime is equal to minus ct prime and x equals to minus ct. Whereas earlier he had that as the positive values. He's now got it as the negative values. So he's taken these two equations, manipulating them, and he's coming up with two equations, and equation which is denoted as 5, and he then manipulates that to get equation 6, where he has v equals bc divided by a, and what he's ending up with is v equals x divided by t. So he's got x is equal to vt. So he now has vt is equal to ct. So you've got v equal to c. And he doesn't really mean that. He doesn't want v is equal to c, but that's what he's got in his maths. And he's got v equals c and also equal to minus c. So the mathematics he's presenting is completely utter nonsense. But from that nonsense, he's then forming the Lorentz equations, which is shown here. And so Alexander summarizes it as being nonsense. And so if Einstein's got people following what he's doing, then they're just happily applying nonsense to things as well. And I pointed out that other people have pointed out similar problems, such as this website here. So the question becomes, are the mainstream ignoring the nonsense by Einstein, and they're leaving it uncorrected, or do they believe the nonsense? And so I considered this New South Wales, Australia, where they're teaching relativity. and the lecturer tells the students to accept what he's saying. Basically, the students don't understand what's being said. The students rebel at what's being said, thinking what being told is nonsense, and the lecturer is telling them that it's supported by experiment. However, if you go to this person who's an expert on relativity, Professor John Norton, he's pointing out the Michelson-Morley experiment is fully compatible with an emission theory of light that contradicts the light postulate. So the light postulate is not given by the Michelson-Morley experiment. So people who are saying that it does are making a falsehood, are lying. So the New South Wales lecturer asked his students to believe nonsense, and he lies to them about experiments. So everything sums up as it's all complete and utter mess. And also it's a mess in logic. And the logic mess is being pointed out in the video that I showed you by Ray Fleming. Try to get back. So hopefully you saw the slides this time. I'll just check a moment to see whether it came out. Yeah. Yeah, it seems like the slides came out. It's unfortunately Franklin went, and I was relying on him to tell me whether the slides were being shown. But it did work in the pre-setup thing. So now if I try to stop the screen, go back to myself. Right, that's it. I'm now open to questions and comments. Sorry about the slides problem, but there seems to be problems all the time with this StreamYard. Originally, I was having problems accessing StreamYard, and I think the person last week had problems accessing it. I've solved the problems of accessing StreamYard, but still end up with other problems and try and use it. So sorry about that. But you've got the basic idea from this talk is there are a lot of mathematical mistakes in relativity, and there are also a lot of logic mistakes as well. The mainstream just seem to be going along with that. And so because of that situation, when you apply all that mess to experiments, it's not leading to any understanding. It's sort of like mess applied to mess. So I try to see what we've got in comments. Anyone going to put their hand up? No. I can see who's there in the green room. So anyone wants to put their hand up. I'll go to the comments, see what we got. I don't know how far down to go. Yeah, so yeah, so starting from here, I'm sorry if there's any interesting comments before this. I think this is where I'm picking it up from. Cornelius says the way he heard or understand it, C is constant in all inertial frames, and that, I don't think that's sufficiently clarified as to what you're taking the speed of light relative to, because you can take the speed relative to inertial frames, and when there was an ether concept, you would be wanting to talk about the speed of light relative to an ether frame. So as far as I'm concerned, the idea of the speed of light is constant, which is in special relativity, that is ambiguous. It's not properly mathematically defined. So so this comment is about YouTube videos. I think Ray Fleming's got a lot of videos. I think no. New physics. Yeah. What trans? So got this one. I'm sorry, I don't understand which transformation based on what. So I don't know quite. Lorentz transformations is what special relativity uses, and Einstein gave some mathematics for deriving the Lorentz transformations, and unfortunately, that mathematics is meaningless. So you can derive anything just using the nonsensical mathematics that Einstein is using. And so the people who believe in special relativity do they accept that what Einstein is saying for the derivation, the Lorentz transformations is nonsense. And I don't know. They have not told me. So yeah, it's based on that, but how the constant light speed fits into that, I don't know. Yeah. Okay, I think Cornelius is waving. So, hello.
That's the Lorentz transformation is based on the assumption that the speed of light is constant in all initial frames. And
Yeah.
as far as we know, that's true, and it's always been measured to be true.
Yeah.
So there's no reason to go against that. So if you're measuring the speed of light in an inertial frame, it's always going to be constant with respect to the time and distance within that frame. You have to utilizing the lab tools, utilizing the same tools, the same measuring rods, and the same clocks that are in that inertial frame. The speed of light will be constant. Even light that comes from outside that inertial frame will be measured constant to any speed of light that comes from within that first inertial frame. So as it passes through, it will still be equal to if you were to set off a light source at the same time a light beam from an external source came through that frame, they would pass through that frame at the same rate in the same distance. So the speed of light within that frame is constant based on the tools you have in that frame to measure that speed. And that's what the Lorentz transformation attempts to work with.
Yeah, but I pointed out the derivation is nonsense. So Einstein's derivation is nonsense.
Yeah, and there may be issues with the mathematics and the derivation in the Einstein, but the speed of light being constant within the inertial frame is what Lorentz transformation is based on.
That's all the words they use, but when you look at the mathematics, Einstein says, well, people say that sort of thing, which you just said, but when you look at the mathematics, it's just meaningless. You get 0 equals 0, and you manipulate that around, and you have C equals minus C equals to V, and they're not really supposed to be the same thing. So the mathematics is just nonsense.
That might be more of an interpretation of the mathematics than
that's the problem. That's the problem with it. It is the mainstream. Do they accept the mathematics that Einstein gave for deriving the Lorentz transformations? Because, from my point of view, and the other people like me, that mathematics is meaningless. So, do the mainstream accept meaningless mathematics, or are they saying we know that mathematics is meaningless and that's not the mathematics we're going by? But if they are doing that, they're not saying. And if the mathematics they think if they think the mathematics is wrong as well, like I do and other people, they haven't corrected it. They've left it uncorrected. So that's the problem with it. And then they kind of like commit logical fallacies, which Ray Fleming was pointing out. So, okay, thank you. Is that it?
That's it. Yeah, that's good for now.
Thank you. So, bye then. Thank you very much. Cheers. I'll carry on now. So, next person. No more hands up. Good. Right. So, if Einstein, is a question says, if Einstein made a lot of math mistakes, does that mean the math isn't accurate according to what reality means, or that it simply doesn't adequately describe only the theories of special relativity? But the problem is the mainstream, the people who believe in Einstein's relativity, are sort of like not acknowledging the math mistakes, and the only person from the mainstream which I think has acknowledged the math mistakes is Professor Ohanian, and he's done his book Einstein's Mistakes. But then he did that, and he got attacked quite a lot. I think the he rebelled against the mainstream, so the mainstream attacked him back. But the issues of mistakes in Einstein's maths are not being addressed. Does the mainstream think Einstein made math mistakes, and hence they're not going by the math that Einstein gave, and hence leaving the maths that Einstein gave uncorrected, or are they believing the maths that Einstein gave and not thinking there are any mistakes in it? And that's the problem with this issue. They're not making it clear what's going on. The mainstream just not answering the question, and the mainstream just seems to say usual propaganda. Einstein is a genius. He's a mathematical genius, and so forth. And they're ignoring the criticism of the mathematics he gave. We're going on with there. So Kev says there are no mistakes in special relativity. Lorentz transformations are easy to derive. Hundreds of videos on YouTube showing it. Yeah, I showed Einstein's derivation of the Lorentz transformations, and I criticized it, and I said it didn't make sense. If there is a great deal with special relativity, there is a great deal of mathematics, and so there is all this other mathematics out there about other ways of deriving the Lorentz transformation, and hence hundreds of videos if you pointed out. And if I went to those, I would criticize the mathematics on those. So that would mean I'd have to have another. They've done 100 videos. I would have to go through each of those, and that's 100 more criticisms from me. So I pointed out that Einstein's derivation of the Lorentz transformations don't make sense, and unfortunately, those other derivations don't make sense as well. But that's too big an issue to be able to go through on this video. So I've only been able to concentrate on the small thing about what Einstein is saying. I don't know. How did Einstein define it different than how Michelson Morley or even others? Well, I was pointing out from Professor Norton, who studied in great detail the things that Einstein's saying. Einstein was looking upon the Michelson-Morley experiment as showing the principle of relativity. He wasn't looking upon it as showing that the speed of light was constant. And it's people that have come after him that are saying the Michelson-Morley experiment shows the speed of light is constant. And that's not what Einstein was saying. So they either have misunderstood what Einstein was saying, or they've put another interpretation onto it. And as Norton was pointing out, it doesn't. The Michelson-Morley experiment does not show light speed as being constant. It instead shows the relativity principle. And if you just go and buy the relativity principle and not by the light speed constancy, then the relativity principle is really part of Newtonian physics. So there's no change. The Michelson-Morley experiment can be understood by a Newtonian physics interpretation without the need of saying the light speed is constant. And that's another problem in the confusion which the people in the mainstream have created with Einstein's relativity. So I wouldn't want to call it Einstein bashing, though. Maybe Einstein questioning. Well, you've got Einstein himself, and you've got Einstein's relativity, and unfortunately, people have put their own interpretation onto Einstein's relativity after Einstein, and so they're not necessarily going by what Einstein is saying. So Einstein said some things, and then people have come after him and decided something else instead, but they still attribute it to Einstein. So Einstein's relativity is the special relativity and general relativity is Einstein's baby, his creation, and it's sort of created then a mess. People have then made a mess of it. I think it was a mess when Einstein was talking about it, and it was still a mess when others have dealt with it. So going on. Yeah. So yeah, the Fitzgerald Lorentz used the Michelson-Morley experiment to suggest the contraction. This was complex, so Einstein used constant light speed to derive transformations. But you have Lorentz's theory, and Lorentz's theory is with an ether, and most people interpret Einstein's relativity as not having an ether. So you've got a conflict between what people interpret as two different theories. So you're trying to say, well, Lorentz did that, and Einstein unfortunately did something else, so it's not really compatible. Yeah. So what this person says, what ideas does the Lorentz transformation convey other than it reducing the velocity of objects that would linearly exceed c? Well, you've got Lorentz's theory and you've got special relativity, Einstein's special relativity, and people interpret these things differently, and the Lorentz theory seems really to be made different to what Einstein was writing about in 1905 with his special relativity. So it does convey different things. It doesn't, depending on the derivation, it does mean different things. So all this idea that you can't exceed the speed of light, well, Einstein never said that. In the 1905 paper on special relativity, he doesn't say speed is limited to light speed c, and that's later interpretations added onto it. And from my view, that's just more mathematical mess being made. Let's see if I get on to other things. Going down. Going on to the issue of ether, so that's not really what I was dealing with. So is it the measure? So hold on a moment then. So this is still ether, but ether isn't what we're dealing with in this talk, but it is still a big issue. Is there really an ether or not? And you can go on to different ether theories. So if it's supposed to be relative to ether or not is another problem. So, okay. Space. Yeah. Yeah. So. Oh. Okay. At a stage. Hello. Hello. Were you waving your hand? Sorry.
Yes, sir.
Malcolm. Okay. Okay. Oh,
I would like to say a few words.
yeah. Okay. Thank you.
I'm absolutely agree with analysis of academia we heard today about. But everything is okay, everything right. But the main question is how to fight against academia with new ideas, how to defeat academia with new ideas. This is the main point. What is most important, it's not only mathematical nonsenses we have in a real Big Bang model. We have even physical nonsense. The guy today, he mentioned microwave background radiation. It's one of the pillars of Big Bang model. But unfortunately, people, they forgot even basic of physics. Expanding universe cause the expanding or the increasing of the wavelengths of each photons. It's a bullshit because there is no mechanism. We don't know what is going on. And what is important, according to the classical definition of black body radiation, it must be in thermodynamic equilibrium with some matter, with some body, with something. There is nothing going with photons during his spreading from the star to us. No way. It should be thermodynamic equilibrium between photons and some body with some temperature. Only then you can introduce this temperature of the microwave background radiation and so on and so on. What is important? Photons that were irradiated 380,000 after Big Bang model, and what we can see right now, I can't take it. We must have somebody. In my model, the microwave background radiation have a very good temperature and everything because there is a thermodynamic equilibrium with intergalactic plasma, and existence of which is already approved, confirmed with experiments. That's why, look, I'm crying about this issue and nobody wants to listen to it. We cannot do something with photons. They don't interact with each other. There is only one way for them to change something, to interact with somebody, with thermodynamic equilibrium with the body. That's why somebody will explain me how to increase the wavelengths of photons. But photons, they don't have even wavelengths. They have only four momenta and that's it. And wavelengths is a classical notion for ensembles of photons. Ensembles, not for each photon. You see, that's why mathematical bullshit, it's okay. Sometimes it's happening. But even pillar, the main pillar, one of them of a Big Bang model, totally wrong. What we're going to do about it? Maybe, guys, they have some other explanation. Maybe somebody will explain me how to increase the wavelengths with photons. And if wavelengths, from their point of view, it's increased, it should be lost some energy. Where is this energy going from? How photon loses energy? I don't know. Thank you so much. I wanted only to...
Thank you. Cheers. Yeah. For one of the problems in our society, Chapel Natural Philosophy Society, is many of us look at Einstein and think Einstein is wrong, but they fixate on different things of Einstein being wrong, and then they come up with a theory themselves. And so if you get 100 people who think Einstein's wrong, it ends up then with 100 different theories. The problem is Einstein has covered a great number of different topics. He's done space-time, curvature, he's done Lorentz transformations, he's reinterpreted times being relative. Einstein has done so many things that there's so many things you can latch onto as being wrong in Einstein, and you then develop a theory on one specific thing of Einstein being wrong. And unfortunately, when you look at Einstein, so I'm trying to point out here, you can't really understand what he's saying. He says a lot of things, then he's presenting some maths, and it doesn't make sense, the maths. So it ends up like it's just a mess. So Einstein's point of view, Einstein's relativity is really just a mess. And so if you want to put a replacement for it, well, we don't have a proper understanding what Einstein's relativity is anyway. And people who are working on Einstein's relativity will just make amendments. I mean, if there's somebody looking at the derivation of Lorentz transformations, they look at Einstein's derivations. All they have to do is not believe his derivation and come up with a different derivation, and then they still call it then Einstein's relativity. Or somebody might look at Einstein's derivation and accept it, and then look at something else that Einstein did and change it. So there's so many changes you can make with Einstein's relativity that it's just making a complete mess of things. So thank you, Vladimir.
No. I'm very sorry, but even Einstein theory doesn't work because there is no vacuum. Speed of light in vacuum. Explain me, what does it mean?
Yeah.
Well, you are talking about mathematics, but physics against your mathematics.
Yeah,
if you're talking about there is no vacuum. There is a medium of the vacuum. There is intergalactic plasma. There is microwave background radiation and all this stuff filling our space.
Yeah.
How to take care about it? What does it mean, vacuum? Do you know something about it? That's why even to discuss special relativity, not so much meaning, because it's mathematical tricks, mathematical equations, and there is no correlation between mathematics and the real cosmos, the real space we live in. What is the reason for it? Why we are wasting our time to talk about the constant of speed of light in vacuum? Because there is no constant, there is no vacuum. What are we talking about?
Yeah, but if you're talking about the ether, if you mean that there's no vacuum and instead there's an ether, then it becomes arguable as to what Einstein meant about the ether. To be sort of 1920, he gave a talk where he seems to be have changed his mind and he accepts the ether. So Einstein just becomes difficult to understand on issues like that. So thank you. Yes.
No. Even ether, it was rejected. It was canceled. But already in the first equations for the general relativity, in 22 already was in 1922, it was introduced perfect liquid. What does it mean, perfect liquid? And there is some pressure, there is some mass density and all this stuff. Do we have ether in general relativity or not? What does it mean, this, perfect liquid or perfect medium? I don't know how to name it. There is no vacuum even in the original equations for general relativity. What are we talking about?
General relativity was a bit further on than what I'm dealing with. I dealt with the problems in special relativity. So thank you. Cheers. Thank you.
Okay. Thank you so much.
Thank you. Thank you very much. Cheers. Bye. Let's see. Right. I go back to the comments. Oh, yeah. I got one here. I got a technical issue here. John Hodge says, "Why am I not allowed into the green room?" ? I think last week there was a talk with you, John Hodge, and you had problems accessing StreamYard, and I've had a lot of problems accessing StreamYard, and eventually what I had to do was get a new computer. So I'm still having problems with StreamYard. So if your particular problems might be solved by a new computer and everything, but if you want to, you can talk to Ian Cowan again about it. Maybe you can clarify things. But I myself still having problems with StreamYard. And it's nothing to do with me. I've not blocked you. It's just we're just having problems. People have problems with StreamYard. Sorry. Sorry about that. In an inertial frame, is an inertial frame always weightless, whether in free fall or within aerospace? That's I think you're talking about weights. That's moving on a bit to general relativity, and I wasn't dealing with that, so that's another issue of problems. That means, and so Kev says that means Roger doesn't understand the maths, not everybody else on the planet. Well, I tried to give examples of other people pointing out that they think the maths is meaningless. So I was pointing out that the maths looked meaningless, and there's other people saying that as well. So it's just not my point of view, entirely my point of view. It's other people I've talked to and other people's papers I've read, and they've looked at the mathematics of relativity, and a great deal of it doesn't make any sense. Yeah, the ether. So you're speaking the ether, and the problem is not actually dealing with that issue this time around. It is another issue, problem. Yeah, it's a problem of how to define the ether. Yeah, that's another problem. Let's see. Yeah. Not something about preferred frame. Yeah. Well, there's a problem with defining what ether means, and also a problem with defining what a preferred frame means. And you read different relativity papers, and they seem to have different ideas of what a preferred frame is. So that's another issue, another problem. So the question says that asking about clarification, and I think that's one of the complaints I have with these relativity papers. They don't seem to clarify their terms and ideas properly. Particularly in this one, I was pointing out the mathematics for what Einstein is using doesn't really make sense. It needs a lot more clarification, and that clarification is not given. Right. Harry, great old Harry. I lost count of all the fallacies of logic that Ray Fleming cited, and I've seen the chat. Yeah, that's the problem. There's far too many fallacies, and people don't get taught logic anymore. It used to be that people were taught logic. So so Robert says Einstein's special relativity mathematics of space and time uses Pythagorean theorem and seems to work across all of mathematics. And it's if you particular bit I was dealing with was the Lorentz transformations and the mathematics for the derivation of that from Einstein didn't seem to make any sense. He's using 0 equals 0. Photons a bit dominant. What point he's making? Yeah. That's it. Yeah. So this is a good point. This is true. The dissidents are not united. Yeah, that's true. Dissidents aren't united. There's some people, dissidents, who believe in Einstein, and some who don't. And those who don't believe in Einstein, well, we don't agree. We don't. if there's a theory to replace Einstein, we can't agree on it. So distance are not united. There's just lots of different distant point of views. So I don't attack distant theories too much. I just mainly attack Einstein's theory or theories for special and general relativity and point out that that's not united as well. The people who believe in Einstein's relativity are not united. They're not presenting one theory. Instead, they're presenting lots of different opinions. If they presented one theory with one point of view, one opinion, and not numerous opinions, then you have something definite to look at and to analyze and try to work out an alternative to. But the mainstream are not doing that. They're just presenting lots of different opinions, and hence there's no unified theory of what Einstein's relativity is supposed to be. Yes. Does anyone speculate that any of the evidence of special relativity was faulty? I think they do, but from my point of view, it's the interpretation of the experiments. People are saying, "Oh, experiments are in agreement with special relativity," but I start complaining about how those people interpreted special relativity, because the way they're interpreting experiments is from lots of different points of view. In what I was pointing out, the mathematics, what I was talking about in this talk was the mathematics for which Einstein derived the Lorentz transformations does not make sense. So the people who believe that the experiments agree with special relativity, what are they doing? Are they saying that mathematics, which doesn't make sense, of 0 equals 0, are they then saying that mathematics is confirmed by experiment? Because they're not explicitly making that clear. So it's just the experiments, how they're interpreting the experiments is just ambiguous. Yep. Yeah. So he says, I'd say most of the distance, yeah, somewhat unite with the idea that certain mainstream ideas have various flaws. Yeah, that's probably right. Many of those who think Einstein is wrong unite on the issue that Einstein's relativity has problems with it, has flaws, but then what the mainstream wants is a theory to replace Einstein, and then that's when the distance fall apart. They don't agree on a theory to replace Einstein. So people who think Einstein is wrong, they can unite and say, yeah, they believe Einstein is wrong, or Einstein's relativity is wrong, but they can't unite on what to do next after that. Oops. Yeah. So most of the talk is now going back to the ether. So it's going back to talking about the ether again. So how would you say the ether theory correlates with Einstein's space-time continuum? So Einstein in 1920 gave a talk on ether, and he seemed to be saying the ether exists, and then it's the problem of trying to understand what Einstein meant by that. And Einstein might have meant that the space-time continuum was the new ether, but then there's a lot of people just going to sort of have lots of different opinions as to what Einstein was trying to say. So it's another mess. It's another area of mess. Yep. Yeah, so this is he's pointing out. Yeah, it seems to be Einstein in 1905 had discarded the ether, and then Einstein in 1920, when he gave a talk, his lecture on ether, he seemed to be accepting it. So yeah, so that is one way people interpret things, but that then goes into a lot of argument. People argue with people about the ether, and it just goes round in circles. So I got another hand wave. So it's Cornelius. So if we just, I know.
Hi. I think I mentioned before that basically in his 1905 paper, I felt like he was just saying that using the mathematics allowed you to make the interpretations without considering the
Yeah.
ether. It
Yeah.
became that the ether was superfluous, but that he didn't necessarily say that the ether didn't exist. He just said that it was not necessary to qualify the equations.
Yeah.
That was my interpretation of it.
Yeah, I agree with that. I think that's my interpretation. But the problem then becomes one of philosophy. So
yeah, because in his Leiden speech, he was clearly even defining what he considered to be an ether. His paper on ether and the relativity, and that 1920 was it? I think
1920 or so.
Yeah, 1920.
Gave a talk on ether. Yeah.
Yeah.
So,
May 5th. Yeah.
Yeah. But back to that, what he says in 1905, ether superfluous is all right. I think it was only in the context of that paper he was talking about. But people do interpret that as meaning if it's superfluous, then you can discard it.
Yeah, that's that's
the problem. So Einstein really needed to clarify: did he mean superfluous in the sense of discard the ether, or did he mean it in the sense of it's still there even if you didn't need it?
Yeah, unfortunately, as you said too, I mean, interpreting it from German to other languages, it loses some information too.
Yeah, it gets what's called lost in translation.
Right.
I've looked in the translation thing, and how a person thinks is influenced by the language they know. So you can think things in a language, and it doesn't really translate properly to somebody thinking in a different language.
Although certainly his 1905 or his 1920 paper on how he does describe ether certainly takes a lot of interpretation too. It's a pretty open description.
But it seems to be a general problem with translation that it's hard to translate from one language to another. There's sort of like translation stories which probably are myth, but they kind of illustrate it that when you translate from Russian Tolstoy's War and Peace, it becomes a better story in English because the people writing the English translation have tidied it up more. So the English translation is a much better story than what's in the Russian. And then you got these stories that I think it was in Star Trek. They have the Mickey taken out in Star Trek film number 5 or something, where the Klingon says, I don't know if it was number 5 or some other number, but the Klingon says that Shakespeare is better in Klingon than it's in English. So that they point out that there is a problem in translation, even in these fictional films.
Well,
which is kind of interesting.
Yeah. What Quest says here about, what he says superfluous and undetectable. Well, the undetectable part is probably the most significant part because Einstein says what it was responsible for. It was responsible for the curvature and the space and time, but he doesn't describe what mechanisms it has to be responsible for those things. And at this point, I don't think anybody really understands what mechanisms it has if it does exist.
Yeah.
And neither did Einstein at the time. He just understood this is what it was responsible for.
Yeah.
Or he believed that this is what it was responsible for. Anyway, that's my comment on it.
Undetectable is a popular word because undetectable problem because space-time curvature gives what would be called what we would observe as a force, a gravity. So space-time curvature causes gravity, and what we would detect as gravity is a force. And well, we don't actually see space-time curvature from how we perceive the world in 3 dimensions. We don't see the world in 4 dimensions. So
Yeah.
it's sort of it's undetectable from how we see things. So undetectable becomes a problem now in Einstein's relativity.
Yeah. I look at, like I said, this curvature being more not just a smooth curvature, but being more like the waves on an ocean. You increase the waves, you increase the distance across across that surface, and it's basically just like if you tension a rubber band or something like that, it can move faster or slower through that rubber band depending on how much tension there is. But when you look at that rubber band, that device, you can't really see the tension change, but you can see the reaction to the motion. You can sense at either end of it that things move faster or slower because of the change within it, and that's kind of how the ether would be. You detect that light changes in it, but you can't detect it, the tension itself.
Yeah, exactly. So if the ether is undetectable,
that's exactly.
If the ether is space-time curvature, well, space-time curvature is undetectable because we don't perceive the world in 4 dimensions.
Well, the space-time curvature would still be detectable. That would be like the waves on the ocean. You can detect it because you can detect the length of time it takes to get from here to there would change.
I mean, in the sense that we don't see in 4 dimensions. What we'd see was 3 dimensions.
Right. Yeah.
Okay.
Okay. Thank you.
So, thank you. Cheers. Right. Okay. Oh. Okay. Oh, Franklin had to stay. No. Hello, Franklin. No. No. Hello.
Yeah, I'm here.
Yeah.
Hello.
You're back. Okay. Cheers.
Yes, I'm in my car here. So.
Yeah, I had problems.
So.
Okay.
So I was just kind of. Of course, I've missed like the first part of the thing there, but you were showing the video there from our friend Ray Fleming, right?
Yeah, that worked, I think.
So but Ray's video wasn't titled like problems with math in relativity. So I was kind of wondering, what were the relevant points that you think people should take away from that video?
Well, okay, that's a good point.
I was so flustered. I was bored.
I was so flustered about the slides not having turned up. So the point I was leading on to was you've got a problem in the mathematics which Einstein has and such things. My example I gave was the derivation of the Lorentz transformations from Einstein. It seems to be meaningless, but the mainstream doesn't address that. It doesn't seem to tell you what does that mean in the sense of should you use different maths or should you be believing that maths? And then I went on to
let's go over that a little bit. So
yeah, okay.
I'm not that very familiar with, say, the math. My understanding is that there's the Lorentz factor.
Yeah.
Which is just the square root of c squared minus v squared, thing. That's the Lorentz factor. Yeah. And then we have things called the Lorentz transform, which I think that should stand alone. I mean, it's not derived from special relativity. Are you? So, I mean, how could that be wrong?
The Lorentz transformations are supposedly derived from special relativity because Einstein started with 2 postulates, and he's supposedly deriving the Lorentz transformations from that. So,
well, is he trying to redefine them? Because I was thinking, well, the Lorentz transforms, those existed before Einstein.
Well, Lorentz theory, yeah.
Yes, Lorentz theory, which is basically ether preferred frame theory, right? So
Yeah.
How
Ether.
could you? I mean, that stands alone. I mean, if you were just, you wouldn't call it a derivation of the Lorentz transformation. That's just another transform, a
Well,
different.
talk about Einstein's theory. Einstein's theory he published in 1905, and it was supposed to be about deriving the mathematics from two postulates: the principle of relativity and the constancy of the speed of light. And he's supposed to then derive the mathematics, and it happens to supposed to be the Lorentz transformations. So his theory, you're supposed to derive the mathematics of Lorentz transformations, and Lorentz had an earlier theory where he had Lorentz transformations. So it's supposed to be, in that sense, supposed to be a different theory because he's
Well,
derived.
I made a very careful read of the 1905 paper, and it's like, I got lost as soon as he mentioned how he synchronizes clocks, and then after that, then the
That's
math
mistranslation. That's where the main mistranslation is.
And then the math in the rest of the paper is completely incomprehensible.
Yeah.
That's when they start using these matrices.
Yeah.
And I can't make heads or tails of the math after that.
Yeah.
I mean,
one of the things that some people have pointed out when they've dealt with that was Einstein aware of complex numbers? Because he seems to be needing to use that in the maths he's using, because you've got the square root of -1. And is he going to using that in when he's got his phi function in? And so it could be that some people speculate his wife was the one doing the mathematics for it. And so then you've got the problem of what sort of mathematics did she know? But sort of like, it doesn't really make sense from Einstein doesn't give references, doesn't cite what he's working from. And so he's jumping into the mathematics and you don't even know what mathematics he's using. So where's it all coming from? It's not clear.
Well, I'm
trying to get back to.
I think they understand what. I mean, that paper is just like so many typical physics papers.
Yeah.
Where you read it, and as soon as you hit like all the Greek, it's like you're completely lost.
It's all Greek to me. That's a famous saying, isn't it, for mathematics? When you don't understand it, all the Greek symbols they use, and then it becomes all Greek to me.
Yes, it's all Greek to me, and that's just not really the way my brain works. My brain works on a more physical basis, right? So when people just start launching into all these equations, I get lost and I get frustrated about these discussions about relativity because at some point it becomes like all of this incomprehensible math, which I can neither confirm nor deny. So I prefer to think of, well, what is the actual physical reality? So I always get back to, okay, is there a physical ether or not, right?
Yeah.
So Einstein said there must be an ether, although he said the most ridiculous thing, which is it can't consist of parts that can be tracked through space. I mean, Cornelius was pointing this out all the time. And I think that's like the greatest bit of nonsense ever. Because if it's not made out of pieces, that means it must be one piece. And then if it's one piece, then how can anything move in that one piece? So that doesn't make any sense. So
I know, but if you, I look at it as a mathematician more than a physicist in that sense. Of physicists are sort of more interested in doing experiments, but sort of if it was a mathematics, and you say, well, somebody's saying a mathematical claim, the ether does not exist. What you would do is you would define what the ether is with some mathematics, and you work through the mathematics and say, and this doesn't work, therefore the ether doesn't exist. But Einstein doesn't do that. He doesn't define terms he's using in his mathematics. And so it just doesn't make mathematical sense what he's doing.
Well, I mean, Harry is always just saying that, well, the problem is that you can't run the math in the same, using two different frames, basically, right? But the math allows you to do that, and therefore that's what the part that doesn't really make sense. I mean, technically, I think that the math itself, if you use it to say calculate the trajectory of an electron in an accelerator ring, you usually have to take into account the relativistic effects, which is just once again the Lorentz factor problem, and making sure that you calculate it with appropriate mass and things like that. So that part of the math works, right?
Some of the maths works, but some of them don't. Because if you sort of like what I was dealing with was the derivation of Lorentz transformations.
Well, that people don't care about that. I mean,
it doesn't make sense. But if you just ignore that and just deal with the Lorentz transformations, then you're looking at just that bit of it, and sort of like you can sort of like make sense of that. But sort of like this is the derivation. If you're just looking at some of the maths, then that little bit can make sense. But if you look at a bit more of the maths, then it doesn't all make sense in the complete thing. And what's it, with Einstein, he's given his postulates, right? So he's given the light speed is constant. And what he ideally needs to do then is write down the mathematics for what the mathematics looks like when the light speed is constant.
Well, no, actually, I mean, I have to stop you there, because Einstein never said the speed of light is constant. Nowhere in the paper does it say that. It says that the speed of light is independent of the transmitter or the receiving velocity. That's what he said, okay? Einstein never, I don't even think he meant to say that the speed of light is
the popular statement of the second postulate is that light speed is constant.
Yes, and I'm saying that my main point is that is wrong.
If we just say the second postulate, you should say the second postulate gives this maths, and if the second postulate is not obeyed, then it gives this other maths. But he doesn't say that. He doesn't clarify what the maths is for his postulates.
Yeah, so I would always argue that he never said that the speed of light is constant in any inertial frame, which is how the second postulate is typically framed by the mainstream.
Well, that's a typical. You've got the principle of relativity as the first postulate, and so the inertial observers observing the same thing. And so when you're talking about light speed, you then adding that to it, you're saying, oh, they should all observe the same thing for light. And that seems to be what they get the idea of the interpretation that he's saying that light speed is constant. He's saying that light speed is the same for both.
A very relevant question here. You know, what does constant mean, though?
Yeah.
Okay, and this is a very important point.
Yeah, that's difficult.
Now, in terms of the postulate, that means that the light travels, how it travels does not depend upon how fast the source of light is traveling. So if you've got a flashlight and you've got it beaming out the front of a plane, then the speed of light, the distance at which it moves over time should be the same, whether it's coming out of the plane, front of the plane, going at Mach 1, or whether it's coming out of something which is not moving at Mach 1, which means that if you, and I describe it as if you were to have a plane and then you just have a light that's sitting on the road, and then as the plane goes by, both of those light sources turn on at the same time.
Yeah.
And then you would watch how the front of the wave travels between the one that was launched from the airplane and the one that was just sitting on the ground. And you would see that if you had like some light sensor beam, that both of those beams would hit that sensor at exactly the same time, meaning that the speed of the airplane did not get added to the speed of the light beam, right? Because if it did, if it were like a bullet, then it would go like at least, Mach 1 faster than the light that was just coming out of the stationary.
One of the interesting points, though, you're right about that, but one of the interesting points is if light acts like a bullet, and then Einstein has done one of his papers where he's treating light as a particle, so how much of that is supposed to carry over to when he's talking about relativity. So it's just a lot of confusion trying to make sense of Einstein's papers. So you're right.
Challenge him to go look at the actual postulate that's in special relativity. What does that say? Does that say the speed of light is constant? It doesn't say anything close to that.
Yeah, it's supposed to be a postulate, but then what is postulate supposed to mean? This is another problem.
I mean, a postulate anyway is just sort of a made-up fact.
Made-up fact, yes.
Made up.
So if you don't want to believe the postulate, you can make up something else.
You have to kind of presume that this is the basis that we're working on, right?
Yeah.
So, but the way it is truly stated is that the speed of light is independent of the transmission source, so it doesn't get added. Mm-hmm. And if you were to observe a light beam coming from something moving fast versus something which is stationary, you would observe this light beam traveling exactly the same distance. That's what it means. That's the constant part. See, so when you ask, what does that mean that the speed of light is constant? It means it's constant with respect to the source moving. So it doesn't matter what speed the source is moving, the light will move at the same constant velocity. So in that way, it's true, okay? But it's not true in the sense that everyone will measure the same velocity everywhere. So it's a matter of what do you mean by constant? That's why I go back to using the analogy of sound waves in air, because the speed of sound is also a constant, right? Although it's not constant in the sense that it's always, say, the same value. I mean, other people get this confused as well, saying, oh, well, light has to travel. No, well, the speed of light is variable, right? If it goes through glass, goes through air, goes through vacuum, it can be slowed down to a snail's pace. The speed of light is definitely not constant in the sense that, say, I don't know, like an electron mass, that's pretty constant. That's the same all the time, pretty much, versus the speed of light, which varies all over the place, right? Yeah. What is constant is with respect to the transmission velocity, whatever it's riding on. So it's not dependent on that. So that's what I think the constant part you should think about. And but the mathematics that people get confused about is that it's like they say, well, if this guy is traveling in this initial frame and this guy's traveling in that initial frame, then they're going to measure the speed of light. They measure it from their own frame. They're going to come out with different answers. And yes, they're going to come out with different answers, but that doesn't mean that the light is traveling at different speeds. What that is, it's an illusion, right? I've used the analogy that if I go look at a ship that's far away, and I put my ruler up to that, and I say, oh, that ship is only 3 inches, right? Mm-hmm. I measure it, it's only 3 inches, right? Because it's like 500 feet away. But that's an illusion, right?
Yeah.
So any speed measurement you could make of light is an observational illusion. So we should disregard all of those observations as being an observational illusion, right? So this is why particularly the statement that you measure the speed of light the same in every inertial frame is obviously wrong. That's just totally wrong. And if you do the actual experiments, if you try to measure the speed of light going from the West Coast to the East Coast versus the East Coast to the West Coast, you find it's different. because the west, I mean, the East Coast is running away from the West Coast, so it actually has to travel further.
Yeah.
But if you, as a measurement thing, just go, okay, how long did it take? What's the distance between Seattle and Boston? You know, you'll come up with different velocities. But in reality, the light is traveling at a constant value with, regardless of who is transmitting, whether you're transmitting from Seattle, whether you're transmitting from Boston. It's, if you compared it with on any other light beam transmitted at the same time, you would find they would hit the same location, physical location, every time, proving that the speed of light was in fact independent of the transmitter, right? So
Okay.
that's kind of because I think we get all wrapped up in that. That's why I go back to more of a physical model, and I say that, I like the idea of
Yeah,
there
but
being
the math, they haven't properly clarified the maths for what they're talking about. So when you
math
say
only makes sense if you have to build a foundation, right? You can't build castles on the sky, because if you don't set some kind of foundation, then, well, you can go do all kinds of crazy things. You can certainly have, say, 4 dimensions and it all mathematically works out, but has no physical reality. So, and an Iron Quest is here asking, don't you accept the idea?
Well, you get physical reality. Well, that's a philosophical problem. People have different philosophies and they interpret.
Yes, well, I like to put a stake in the ground. Yeah. I like to say, I know for a fact, I'm pretty sure things like electrons exist, right? So even though I don't know what an electron is, if you ask me what that thing is, it says, well, I'm still looking for a decent answer on what that thing is. But I'm pretty sure that from all the experiments, they exist, right?
Yeah.
So from a philosophical standpoint, I think that's the rock I can build my church on, which is that electrons exist, right? So all I do is I fill the entire universe with a solid wall of electrons, okay? That gives me, say, my ether, right? Then you can do the mathematics on that, presuming that there is some substance which is made out of particles that you can track through space. Then, only then can you start establishing absolute standards for, say, velocity, right? So if you have such an ether frame, then there is no relativity, that things are going to travel at definite and measurable speeds, and that you have to measure those speeds according to the stationary frame created by that medium. And so mathematically, that's the only way you can provide, I would say, a solid foundation, right? So that's kind of why, I like the ether. That gives me the nice solid frame of a preferred frame. And then we don't get things like the twin paradox, because twin A will be traveling at an x speed absolute speed. Twin B will be traveling at another speed, which is absolute and not relative. If you can throw away relativity if the ether frame exists, and then twin A will never be older than twin B. There'll be some difference in age, but you can calculate it based on the ether frame. See, that math makes sense to me, right?
Yeah.
None of this, oh, well, the twin A can go and think that it's the stationary one, and twin B can think it's the same. No, there's only one stationary frame, which you would have to measure, and you could measure this, where this is, by finding out, say, where time flows the fastest, basically, right? You could do an experiment and send out clocks in every which direction, and then bring them back, and whoever's got the fastest clock, that must be the stationary frame. That's one way.
Yeah, I like to think that
that kind of gets back to the question of what's my view of time
if you've got
dilation.
the twin paradox, then I like to think of it in terms of if one twin's got a clock that's different to the other twin, then somebody's clock is 40, or both of them are 40, and there's nothing to do with time being different. It's but when the mainstream talk about the twins, they talk about time being different. So the twins, one twin has aged more than the other twin, but I like to think of it in terms of the clocks of 40.
Yes, well, I mean,
They
that's an
don't,
interesting point here, which
yeah,
is either you can view it that that it's just a problem with the clocks, right? The
yeah,
clock is just
yeah. The clock
not
effect.
terribly
It,
accurate
yeah,
in the environmental conditions. I mean, it
yeah,
used to be very hard to make an accurate clock,
yeah.
like a
There's a book.
grandfather clock, because
Yeah,
the pendulum gets
yeah,
longer depending on whether
yeah.
it's cold or hot,
There
right?
was a book, I think, a documentary on early clocks, and you go on a ship, and the clocks would, sailing ships and that, you go around the world, or your clock would play up. You had to find a way of making your clock still work, even though you were moving
Yeah,
in
so
the ship.
so it could be a clock problem,
Yeah, so it was a
or
clock.
the other
It was a
thing is
clock problem.
that
Yeah,
the actual
yeah,
time, like everywhere and
yeah,
everything,
yeah,
actually slows down
yeah.
physically.
Exactly.
That
Yeah,
means that there is no clock you could
yeah,
build that could resist that change. So, in some sense, for the particular item going at close to the speed of light, then in that way, you could truly say that for them, time slowed down. And the
yeah.
fact that the clocks slowed down is just, just a
I think
measurable side effect of.
there's also a book pointing out that Einstein was a patent clerk, and the issue that came to the patent office, a big one, which he was dealing with, was about clocks, where they were setting up a network of railways, and the trains were going from one place to another, and they had to have all the clocks in these different places to agree at the same time. So they had a clock synchronization problem. So you had to make the clocks all work the same. You sort of like you set up at one station, and the time say 10 o'clock, get to the next station, and the clock might be working
Let's
in a
not
different
talk
way,
about
and it'd be showing a different
what
time. It won't be
what do
saying.
you think about this general statement, which is a statement often given to dissidents,
Sorry.
which is that so Franklin argument amounts to I don't understand it, so it's wrong.
Yeah.
Which I would respond to say, no, I understand it, and I understand it's wrong because it does not adopt a solid foundation, which would be, say, a preferred ether frame.
Yeah.
Once you adopt a preferred ether frame, then everything makes sense. It
Yeah.
matches the experiments, it matches what we observe in GPS, and we don't get these paradoxes. I mean, special relativity should have been thrown out from the get-go as soon as someone mentioned the twin paradox, and that should have been the end of it. Really, that should have been the end. It said that's nonsense. It should have. I mean, that's obviously wrong. That's what a paradox is. Obviously wrong to the most casual observer, right?
Trouble is that Einstein became famous in 1919, and they said general relativity has been confirmed. They've observed the starlight bending, and then they sort of like adopted everything he'd said from 1905 onwards. Well, most of what he said from 1905 onwards, and some of it they did drop, but they sort of like that because they said, "Oh, general relativity has been confirmed." They then decided special relativity had been confirmed. So it was suddenly forcing on them all of this confusing mathematics from Einstein, which is very difficult to understand what he means. And as I pointed out in the video, doing some of this maths he's given, it seems meaningless. So when they say Einstein's relativity is confirmed, do they mean they believe all of this meaningless mathematics, well, what looks like meaningless mathematics?
No, it just means that they've applied the Lorentz, the Lorentz transform. What do I call that? They applied that formula, calculated additional mass.
They applied
the correct answer, or they've calculated time dilation and
they've used the Lorentz transformations, but they haven't made it explicitly clear as whether they accept the mathematics that Einstein used to get the Lorentz transformations.
Well, the thing is that they've done is that they've used the the Lorentz transformation, assuming that there is one. I mean, we
Yeah.
had Andrew Castro, and it's like, well, we always use the frame of the center of mass, right?
Yeah.
As long as they use one frame, call that the stationary frame, like Einstein did in his 1905 51 times. As long
Yeah.
as you declare that stationary frame, then
Yeah.
everything works fine. Where you have the problems where you say, well, I've got this stationary frame. Well, this stationary frame is just as good, and this frame is just as good. So we should be able to use them at the same time and come up with. No, you can't do that. No, that's wrong.
Yeah. So it's all very difficult to understand what's supposed to be meant. It leads to arguing.
Now, we have the question here. Were all the time dilation experiments faulty? Right. And it's like, well, no, all the time dilation experiments, prove out the time dilation equation is what it does.
But call it clock dilation or clock retardation.
Yeah, like I said, it's
not an effect on time, it's an effect on the clock.
Me personally, I think that if you were to base a clock off of how long it actually takes for an electron to make a transition to one level, which I think is the fastest thing anything can happen. If you were to make a clock actually based on that clock would be immune to time dilation effects, that you would see that clock, which is running at the fastest possible rate in the universe, it would not matter how fast it's traveling. It would maintain its stately rate.
Okay.
No matter what speed it was traveling. That was be kind of my prediction, right? So I'm waiting for them to design such a clock because I think they're working on one. I think they're getting close, and when they do, they'll find out that it's you could send this thing up into space and it ticks at exactly the same rate, right? It'd be beautiful. You don't have to do these corrections anymore. You could have all these clocks simultaneously running around in every single velocity there, and they would still all report exactly the same time. But we're not there. I mean, right now we have atomic clocks, and their heart is actually a quartz crystal, which is literally a vibrating crystal, macroscopic, and that is actually.
I think we're running out of time.
That is what actually controls the atomic clock. It's not actually the atomic part.
Frankly, I think we're running out of time now. I think we've got to close up.
We got about maybe 3 minutes. So why don't you go ahead and
say thank you.
Hopefully people have been
thank you
interested in the discussion at least. So
okay, thank you. So I think around closing it up now. Thank you for everything, and everybody else for their contributions. Sorry about the problem this time with the slides. Hopefully, as I do more of these, things will be easier. Today I came on as a presenter, so learned a few more new things. But getting back to Einstein's relativity, there's a lot of things in Einstein's relativity which need clarification, and the mainstream that believes in Einstein's relativity don't seem to want to clarify those things. They're just going to leave things ambiguous. And Ray pointed out the logical fallacies which the mainstream go into, like the fallacy of going by authority. So the mainstream make a lot of mistakes with their mathematics, and then the lecturer will tell the students to believe that because it agrees with experiment, but really the lecturer, as I pointed out, was misrepresenting the experiment. So you've got all these logical fallacies going on from the mainstream. So thank you very much, and I'll go now. Thank you. Bye. Closing down. Cheers. Bye, everyone. Bye. 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 Cheers. End. Right.